Hello everyone and welcome to day 2 of radicals. So today we're going to talk about how we simplify radicals that have variables in them. So there are some examples down below, but I'm going to zoom in here and see if I can't get this to work because it's been a little funky today. There we go. So just some things that we need to keep in mind when we're talking about variables. Usually if they're underneath of a radical symbol, they have an exponent on them. So in order to simplify variables with exponents, we need to keep in mind what kind of radical we're talking about. So if we're talking about a square root, those need to come in multiples of 2. So that needs to be multiples of 2 because what happens when you square root something is you're talking about what two things multiply by itself to give you that answer. So for example, if you had a squared, if I took the square root of a squared, it would just be a, because a times a is a squared. If I undo that, I get back to a. For cube roots, these guys must be multiples of 3. And for fourth roots, these guys must be multiples of 4, right? That makes sense. So I want to break some things down here. So starting off with just our number, let's make sure that we know what kind of root we're talking about. For this one, we're talking about a square root because we don't have anything in our index spot, which tells us that it's a square root there. So when we're talking about square roots, let's start with just this number. And we need to think about how can we break this number apart. So what perfect square goes into 32? Well, 16 goes into 32, so I could talk about the square root of 16 and the square root of 2. So 16 times 2 gives me 32. We know what the square root of 16 is. That's 4. So really, we have 4, the square root of 2. And that's just when we're talking about that 32 part. Now let's talk about this square root of x to the 4th times y to the 9th. So I want to start with just the x to the 4th. So this is x times x times x times x, and then y to the 9th. So remember I said that to undo these things, they would have to come out in pairs. So as long as I have pairs, they can come out. Here I have 2 pairs of x's, so that means that 2 pairs of x's can come out, so an x squared can come out. Then I would have no more x's because I've dealt with this and I've dealt with this. So now we need to talk about what happens with this y to the 9th. So I need to think about how many pairs of y's are there in y to the 9th. So let me make this a little bit smaller so that I can have some room to draw out those 9 y's. So I'm going to put this down here too. We also have an x out as well now, an x squared out. So then when we're talking about this y to the 9th part, we've dealt with our x's. Let's talk about these 9 y's. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So they need to come out in pairs. So 1 pair, 2 pairs, 3 pairs, 4 pairs. So I have 4 pairs, which is y to the 4th. And I still have this 1 y left over because it doesn't have a pair. So we can't take it out from underneath of that radical. So we still have that y in there. So if we talk about how we can simplify something such as this, well, we need to look at what's on the outside. So this 4 is on the outside. This x squared doesn't have a radical, and neither does the y to the 4th. So I'm going to have 4x squared y to the 4th on the outside, and then on the inside I still have this radical 2 and this radical y. So on the inside we have 2y. So again, I just looked at how many pairs of x's did I have. So if I have x to the 4th, there's 2 pairs in there. That's where this x squared came from. And if I'm talking about y to the 9th, I have 4 pairs with 1 left over. So that's why we have this y to the 4th with 1 left over. And then the numbers, again, that came from simplifying that 32 down a little bit more. So this is going to be my answer for that first question. Let me put a little box around it. Okay. So far, so good. These will get a little bit easier the more that you do them. So again, we're going to start with the number. So 324, that's actually a perfect square, and it's 18. So I have 18 on the outside. Okay, check off that part. Now I have a cubed. A cubed. So how many pairs are in a cubed? Well, if you want to think about it as a times a times a, I have one pair with one left over. So that means I'm going to have one pair that's going to come out, and I'm going to have one left over. So then what if we talk about the square root of b to the 7th? How many pairs are in there? So how many sets of 2 can I fit in there? Well, I can fit, let's see, the closest multiple would be 6, and there's 3 sets of 2 and 6. So we could have this be b cubed with one left over. So I have ab on the inside. So I'm thinking about how many sets of 2 can I fit into the number. So when we were talking about a cubed, I can only fit one set of 2 in there with one left over. When I'm talking about b to the 7th, I can only fit 3 sets of 2 in there with one left over. So we just kind of have to rationalize it that way. And then this would be our answer here. 18ab cubed square root of ab. That's going to be our answer. Okay, so that's with square roots. A similar thing happens with cubic roots. So with cubic roots, again, we need to talk about the number first. So the cubic root of 216 there, well, that's 8. Oops. So the cubic root of 216 is 8. Okay, that deals with my number. So now let's talk about the cubic root of m cubed. So how many sets of 3 are in m cubed? Well, there's only one set. So 1 m comes out. Fantastic. We can be done with the m cubed part. Now, what about the n to the 6th? So the cubic root of n to the 6th. So how many sets of 3 go in to 6? That answer is 2. So n squared is going to be my answer there. So this one would be your final answer for that question. 8, because that's the cubic root of 216. M, and then n squared. So there's only one set of 3 in, oh goodness gracious, in m cubed. So that's where I get my m from. There's 2 sets in n to the 6th. So that's where I get my 2 from. Okay, let's keep going. 56, I need to break down this 56. So what is a perfect cube that goes into the number 56? So if we think back on our cubes, I can break this apart into the cubic root of 8 and the cubic root of 7. So we don't know what the cubic root of 7 is, but we do know what the cubic root of 8 is, and this is 2. And since we don't know what the cubic root of 7 is, we just rewrite it. It was an ugly 7. So that takes care of our cubic numbers. Now let's talk about our variables. So when we're talking about r to the 8th, how many sets of 3 can I put in r to the 8th? So we think about our numbers. The closest multiple without going over 8 is 6. So how many sets of 3 are in 6? Well, that's 2. So this is going to be r squared. And how many are going to be left over? 2 as well. So far, so good. So now let's talk about this cubic root of s to the 4th. So how many sets of 3 are in s to the 4th? Well, there's only 1. So we would have an s, and then there would be 1 left over, so the cubic root of s. So last step, if we put all of that together, we have our 2 on the outside, we have r squared on the outside, we have s on the outside, and then underneath we have 7, r squared, and s. So this is going to be our final answer there. Okay. Let's do another couple. I think I'm going to do these last 6 with you, and then I'm going to let you go on your own and see what you can do with the rest of them. So again, we always start with our numbers. So negative 64, we need to think about what is the cubic root of negative 64. And this just happens to be a perfect cube. So it's negative 4 for our number there. If we're thinking about the cubic root of 10, or of x to the 10th, sorry, we need to think about how many sets of 3 are in 10. So there's 3 sets in 10 with 1 left over, because I would have 3 sets of 3 x's, which makes up 9 x's, and 1 more would give me 10. We all following there? Now let's talk about the cubic root of y to the 21st. So how many sets of 3 are in 21? Well, there's 7. So we have y to the 7th. So now if we put all of that together, we have our number on the outside, which is negative 4. We have an x cubed on the outside, and we have a y to the 7th on the outside. What's left underneath of our cubic root is just x. So we get this final answer here in the purple. Number 14, we need to think about a perfect cube that goes into 81, because that's not a cube on its own. So we can break apart this, and if we do that, we can do negative 27 and 3. So we know what the cubic root of negative 27 is. That's 3. We don't know what this is, so we're going to leave it. All right, so this is inside. This is outside. This 3 is inside. This 3 is outside. So let's go ahead and start to draw that part. Lots of 3's there. All right, if we talk about the cubic root of p squared, how many sets of 3 are in 2? Well, you can't make up a set of 3, so nothing changes, and we're going to stick with this on the inside. If we talk about q to the 12th, how many sets of 3 are in 12? Well, that's 4, so q to the 4th. So our final answer is going to be 3 on the outside. We have a q to the 4th on the outside. And on the inside, we have our number 3 and p squared. So all I did was look at all of those things that I just solved for. So if you compare my numbers, I still have a 3 on the outside, 3 on the inside. If we look at our p values, I still have that p squared on the inside. And if we look at that q value is on the outside now. So 4 more to go, and then you guys are going to try these all on your own. So for this number 15 here, we actually just have variables this time. We don't have to think about any numbers. So let's think about how many groups of 4 can I make out of 4? Well, I can only make 1, so we just have a W there. And then I look at V, and I think, how many groups of 4 can I make out of 17? Well, the closest I can get is 16, and there's 4 groups of 4 inside of 16, and then I would just have 1 left over to get to 17. So my final answer here is going to be a W on the outside, a V to the 4th on the outside, and then the 4th root of V. Everyone understanding that part? So then we're going to come over here to our next one, and this one has a value that we need to think about. So 48, we need to think about how we can break 48 down, because it is not a perfect 4th root. So 48 can break into 16 and 3, and 16 is a 4th root, but 3 is not. So the 4th root of 16 is 2. and then we just leave the other part in there. So this is one part of our problem. And then we think about m to the 8th. So we think about the 4th root of m to the 8th. How many groups of 4 can I fit in 8? So that's 2 with none left over. And then I think about the 4th root of n cubed. How many groups of 4 can I fit into 3? Well, I can't fit any, so we keep that. So when we go to write our final answer, we have a 2 on the outside. We have an m squared on the outside, and we have a 4th root of 3n cubed. So again, I just did that by looking at what are the things that got freed from that radical and what were the things that had to be kept under that radical symbol. And the more that you do this, the quicker that you'll be able to solve these without having to do each step. So just by looking at number 16, I could have done that one in one simple step, but since I'm explaining them to you guys, I'm kind of breaking them down a little bit more. But if you can do that, I mean, go for it. Just make sure that it's the correct answer. So when we go to number 17, 625 just so happens to be a perfect fourth. And it happens that it's 5. So our number turns into just 5. And then we need to talk about the 4th root of c to the 23rd. So we need to think about how many times does 4 go into 23 without going over. So that happens to be 5 times. And 5 times 4 is 20, so we are left over with 3. And then we need to look at the 4th root of d to the 11th. So how many groups of 4 can I fit inside of 11? Right? So that happens to be 2, which is 8, and I'm left over with 3 to get to 11. So when I write my final answer, I write all my outside stuff first. So my number is 5. My first variable is c to the 5th. Second is d squared. And then underneath of my fourth root, I have c cubed, d cubed. All right, now this last one, this part right here, this is like thinking about y plus 3 times y plus 3 times y plus 3 and over again for 8 of them. So I'm multiplying y plus 3 times itself 8 times. So what I need to think about is how many groups of 4 can I fit into y plus 3 to the 8th? So how many groups of 4 are in 8? Well, there's only 2, so that means that this is y plus 3 squared. That's what this is equaling so far, because I can fit 2 groups of 4 inside of 8. So if I wanted to solve this further, I would just multiply y plus 3 times y plus 3. So if I do that, I'm going to write that out right here actually. Y plus 3 times y plus 3. So if I do that multiplication, I would have y squared plus 3y plus 3y plus 9. Simplify it one more step, and I would get y squared plus 6y plus 9, and that would be my final answer. So I will give you some problems to do today for your assignment. And please, please, please let me know if you have questions or if you need to do like a one-on-one conference. So that way we can do that tomorrow or today, sorry. Just because I don't want you guys to fall behind on this. So we're going to have you do this today, and then I'm going to have you practice again tomorrow as well with solving them without variables and with variables. So the problems that I would like for you to complete are 11, 12, 13, 14, 15, 16, 17, 18, and 19. So 11, 12, 13, 14, 15, 16, 17, 18, and 19 is your assignment for today, which are linked below in this assignments tab.